Okay, calorimetry problem. We have a 328 gram sample of water. Just going to draw my little beaker. Here's my water in there, and it's 328 grams. And it absorbs 5.78 kilojoules of heat. If the water has an initial temperature of 35.3 degrees C, what will be its final temperature? So I read this and I realize I'm going to need Q equals MC times T final minus T initial. So now we need to identify what information we have. So our system is this water because the water is absorbing the heat. And the 328 grams, that's going to be M. That's the mass. So I'm going to put that here, 328 grams. I was given C, it's right here, so I'll put that in 4.184 joules per gram degrees C. It's asking me what is the final temperature. So that's what I'm solving for, and it tells me that my initial temperature is 35.3 degrees C. And I am told that it absorbed 5.78 kilojoules of heat. So Q, it's going to be positive because our system absorbed the heat, and that's something that the system gained. It's 5.78 times 10 to the third 5.78 kilojoules of heat. But if you look at our units over here, we have grams, and grams will cancel there. We'll have Celsius that will cancel here, but we have joules. So we need to change this Q into joules. So 1 kilojoule is 10 to the third joules, and that's because kilo means 1,000. So the Q that we need to use in the equation is 5.78 times 10 to the third joules. So I'm going to put that over here. Okay, so from here on out, it's really an algebra problem. And if you multiply those two numbers first, we get 1.37 times 10 to the third, and then it's T final minus 35.3 degrees C. We want to isolate TF, the final temperature. So in order to do that, we need to move this over here, but first we have to distribute. So we're going to multiply 1.37 times 10 to the third times TF. And then we're going to multiply it by 35.3, and I get 4.84 times 10 to the fourth. And that's going to be equal to 5.78 times 10 to the third joules. So the next step is to add 4.84 times 10 to the fourth to both sides. And with that, actually I don't have that number offhand, but after that we will then divide, so this plus that turns out to be 5.418 times 10 to the fourth. To get T final by itself, I have to divide both sides of the equation by 1.37 times 10 to the third. And when I do that, T final comes out to 39.6 degrees Celsius. Now, you always want to check your answer. And so remember, our system is this water. It started out at 35 degrees C and it absorbed heat. So the temperature should be higher than 35.3. If it's not, then there's probably a sign error somewhere. And since my final number is higher, 39.6 degrees C, then that is a good indication that I've gone in the right direction.